Water is a gift of the divine. We depend on water for various reasons, for various purposes. And one most important thing among them is irrigation. As you know, India being a tropical country, the rainfall is not evenly distributed and it is not evenly timed. During certain part of the year, the rainfall is more. During the other parts of the year, the rainfall is less. So what happens when the rainfall is more? As you know, there will be floods. And when the rainfall is less, there is famine and disaster. We will not be able to raise or grow crops. So what are we to do? We have to harness water from various natural resources and use them as and when we need them. So in this class of irrigation engineering, hope you are all prepared to learn a little about distribution works. So you have seen in your previous class the necessity of dams and so on. Such a system is called a storage irrigation scheme. A storage irrigation scheme is one in which you construct a solid dam across the river and then you store the water which is to be distributed to various parts of the command area. When I say command area, it is the area which is to be irrigated. That means the area or the lands to which water is to be supplied. Okay. There is another method which is called the direct irrigation scheme, in which we construct a weir or a barrage to raise the water level, and from there, on raising the water level, the water is distributed to areas where it is required. Now, just see here, what is a distribution work or canal distribution work? Just watch this slide. Civil engineering structures constructed to distribute the water from the headworks to the command area through a network of canals is called the distribution works. It means, you see, we have to construct certain hydraulic structures in order to distribute the water, is it not? And where do we construct these structures? We construct these structures at the point where the canal takes off from the river. So such civil engineering structures which are constructed, and what is the purpose of the civil engineering structure? To distribute the water from the headworks. Headworks is the one which regulates the water. Fine. This is constructed in order to distribute the water to the command area. And how is this achieved? It is achieved through a network of canals. Fine. Do I repeat it? A civil engineering structure which is constructed to distribute water from the headworks to the command area through a network of canals is called the distribution work. In this class, these are the various topics I would be covering. One is canals, classification of canals, methods of canal alignment, cross section of a canal in cutting, embankment, partial cutting and embankment, what is meant by berms, their standard dimensions, balancing depth of cutting, canal lining, necessity of lining and types of lining. In addition to that, we will also see the importance of maintenance of canals. And here, just watch this slide. Here is a topo plan showing the barrage and the canal system. This is a plan picked up from the Vamshadhara project. As you can see, this is the river. You see the river flowing. You would have heard a Telugu proverb which says, Neeru Pallamerugu. You see the water, the river takes its own course, it follows the pattern, and its goal would be to reach the sea. Ultimately, it reaches the sea. And now, you can see here, this particular one is a barrage. Why do we construct a barrage? In order to raise the water level on the upstream side. This part is called the upstream side, and this is the downstream side. You can see the river flowing. Across the river, a barrage or a weir is constructed. I hope you all know a weir is a structure which retains water because of its solid wall. The wall has a more retention capacity than the crest gates which are constructed over the weir. Okay, and the barrage retains the water because of its crest gates. Now, why do we construct a barrage here? So that the water level here on the upstream side is stepped up, it is risen, and then you see we pick up some canals. Some canals are constructed here. This is the left main canal of this particular Vamshadhara project. This is the right main canal. Okay, you need some mechanism to distribute or to supply water uniformly to the fields. How do we do that? You see, this main canal, it brings some water from the river. This canal is constructed from the upstream side of the river. This is the left main canal, this is the right main canal. These two canals bring some water from the river, and from these canals we construct, these are called the main canals, right? These are called the main canals. From here a network is established. You see this green part over here all along is the area which is to be irrigated. This left main canal will cater to the needs of about 1,50,000 acres of land here, and this right main canal takes part of the right side. Okay. I repeat, a barrage or a weir is constructed across the river in order to increase the water level on the upstream side, from where a canal on the left side, if necessary another on the right side, are constructed in order to supply water to both the sides of the river. And now let us see what a canal is. Can you just imagine what a canal is? It is a man-made structure. Why do we make it? It is an artificial means of distributing water to the required area. You see here, canal is an artificial channel constructed with side banks so as to carry the discharge. When I say discharge, it means the volume of water which is sent to the fields. You can see the backdrop here. Hope you all can see this background. That is a canal. It is a man-made one, and hence we say it is an artificial channel. It is constructed with side banks. Bank means this one. This particular portion is called a bank. The purpose of a canal is to carry discharge, to carry water. Fine. And now, classification of canals. So, we need to classify them based on certain criteria. Let us see the classification now. Based on the nature of supply. As I have been stressing, water supply or the rainfall is not uniform throughout the year, right? And based on the nature of the supply, here is the classification. One is the permanent canal, second one is the inundation canal. Let us see what permanent canals are. You see here, a permanent canal is one in which water is available throughout the year. Okay? Here, water can be drawn throughout the year by means of some regulatory works. The head regulator can be operated, the gates can be lifted, water is stored there. Fine. Water is stored in the reservoir or a dam is constructed across, and this water can be drawn as and when it is required. Fine. And water is available throughout the year. Based on the quantity of water which is required for the purpose, the gates are lifted and accordingly water is supplied to the fields. This does not depend upon the rainfall, okay, intensity of rainfall. And now, what are inundation canals? See here, inundation canals are one in which water is available only during monsoons. That means there is no regulatory work which is needed. As and when rain falls, that is distributed along with the help of the network of canals. Therefore, whenever it rains, the water is carried off. Okay? I mean, even the floods are carried off. So, in this particular type, water is available only during monsoons, that is, whenever there is rainfall. And now, see, there is another criteria on which we classify the canals. So, whenever an irrigation project is designed, so what would be the aim of the governments, or what would be the aim of the regulatory authorities? They would like to generate some funds from that, is it not? It is better if the canal would be able to raise some income from that particular project. So, based on the funds available, the canals are classified as productive canals and protective canals. You see, all the time we cannot take up a project for money alone. Sometimes it is possible to generate money from the project. Sometimes the interest of the public may be more important, may be of much higher concern. Then we take up the protective canals. Let me repeat, a productive canal will be able to generate some money out of it, and a protective canal will be able to cater to the needs of the public. Okay. Now, please take down this definition. A productive canal is one where the total annual income from the canal exceeds the annual maintenance expenditure. It will not be sufficient if you construct a project, you have to maintain it. You need money for construction as well as maintenance of the project. So, here the money generated or the revenue generated from the project will be more than the annual maintenance expenditure. Fine. So, the governments will be happy with it. And now, let us see what a protective canal is. Now, have a look at this slide. A protective canal is planned in such a way that the needs of the public are served and no income is expected from them. Okay? And in this particular type of canal, much stress is given to the needs of the public. Fine. And now, methods of canal and alignment. Just imagine a valley. Imagine a valley, and that is where usually the water is stored, the water is ponded. So, you have to align a canal, you have to make a canal right from the place where the water is stored till the command area. The area which is to be irrigated may be much far away, it may be hundreds of kilometers away from the place where the actual ponding is being done, actual reservoir part. So, for this purpose, you need to align the canal in such a way that the velocities of the water being carried does not exceed the limit. The velocity must be fine, it must cater to the requirement, and then the section must be good, it must not cost you more. Keeping all these factors in mind, you have to align the canal. Okay. There are various methods. You may have to align the canal in a plain area, in a hilly area. It does not matter for us. For irrigation engineers, the work concerned is complex, intricate, still we would love to do it because we will be able to feed the growing population. Now, let us see the methods of canal alignment. As a contour canal, the first type of canal is a contour canal. The next one is a watershed canal or a ridge canal. Next one is a side slope canal. Fine, I repeat, the various methods of canal alignment are as a contour canal, as a watershed channel or a ridged channel, and next one is the side slope canal, right? And now let us see what a contour canal is. A contour canal follows more or less one contour. A contour is you would be aware of what a contour is. It indicates the level of a particular area. They can irrigate only on one side of the area, as the area on the other side is higher due to higher contour lines. So, you just imagine a slope like this. The level here will be lesser than the level here, and this will be of a much higher level. Okay, I will show you a slide too. Just imagine a slope, a hill slope. This level will indicate a lower level. This will be slightly higher. The next one would be much higher. Fine. And this particular level we refer to as a contour. Now see this. These are some contour lines. This is a valley. Okay. As you know, the river would always flow in the valley, right? This is a higher level. This is a much lower one. This is much lower. Okay. And this particular dotted lines would indicate the contour lines, or a canal which is aligned along the contour. Okay. Now see here, I have been telling you water would always take the direction along the slope, downward slope. So this is a natural drain. This arrow will show you a natural drain. This would flow downwards. The water in the drain would flow downwards and meet the river. You have to carry water along the contour, and in such a case, this particular contour canal may have to cross the drain here. Okay. You see, this contour canal and the drain are crossing each other. At this junction, we need a work called cross drainage works. This block, as you can see, is called a cross drainage work. What is the purpose of a cross drainage work? It allows the water from the canal to flow without any obstruction, and at the same time the canal can also, the natural drain can also flow. Okay. And now see, this is the contour canal and this is the natural drain. This is how a contour canal is aligned. And now, the contour canals have to cross a number of cross drainage works as the natural drains flow across the contours. I was just telling you, the contour canals may have to cross some drains, and at the junction we have to provide a cross drainage work to facilitate free and unobstructed flow of both the canal as well as the natural drain. What is the next one? The next one is a watershed canal or a ridge canal. What is that? What is a watershed? So imagine an area like this, a sloped area. So naturally, the water along this slope would flow in that direction. The water along this slope would flow in this direction. So this top ridge, this top portion here can be called as a ridge. That is an imaginary line. Fine. For our convenience, we imagine a line along the ridge, and such an imaginary line is called a watershed. Where does it pass through? It passes in an area which has a downward sloping ground on either sides. Fine. Now see this. A channel aligned along such watershed is called a watershed channel or a ridge canal. Now see, you have seen a valley where we have aligned a contour canal, is it not? Now here is a watershed canal which can be aligned along the watershed or the ridge. This crest portion, I have told you, it is not exactly triangular or something like this. I just want to tell you that this is the top portion. Okay. And now see here, this is the natural drains. You can see two natural drains here. Obviously, water takes the downward slope, water flows along the slope, and when you imagine a line along the central portion, that particular line which is dividing these two areas, this entire area can be called as a catchment area. Okay, this area, this total area can be called as a catchment area. And imagine a line at the middle. Yes, here is the line. That particular line is called the watershed line, okay, or a ridge line. And when you make a canal along this line, it is called a watershed canal. Can you tell me, or can you just guess what the advantages are? You can see here, this is a drain, this is another one, and under normal conditions, a watershed line will never cross a drain. A watershed line will never cross a drain. And obviously you don't need a cross drainage work, which is very expensive. Expensive means costly. So the cost of the project will be lessened. It would be enormously reduced. So preferably wherever it is possible, you can go in for a watershed canal. Fine. Now, the third type of canal is the side slope canal. Okay. They are parallel to the drainages, and hence drainage crossing will also be less. Similar is the case with the previous one, where the cost of cross drainage works will be less. So is the case with a side slope canal, where they are parallel to the drainages. Now I will show you how a side slope canal looks. Okay, they are aligned at right angles to the contours. In the next slide, I will be showing you how a side slope canal is aligned. Okay, they are aligned at right angles to the contours. And now see here, fine. This is a contour. Again, this is the slope. Slope is something like this. This is a higher level, this is the next higher level, much lower level. You have seen in the previous cases, a natural drain would flow in this direction. There can be a drain like this, another one like this, another like this. And here is a side slope channel. You see, it is parallel to the drains, the possible drainages. Okay, they are parallel to the drains, and hence cross drainage works will not arise. The necessity of cross drainage works will not arise. And now, next let us see the layout of a canal system. What are the various areas which are involved with a canal system? The first and the foremost thing will be a canal headwork. You need a mechanism to draw water from the river and divert it into the canal. Is it not? From the main river, you need a mechanism to divert the water into the canal. And this is where the canal headworks play an important role. Okay. The next is the head regulator. This regulates the inflow, the flow of water into the canal. The next one is the main canal. I have shown you in the first slide a main canal which is formed right from the river on the upstream side. Next is a branch canal. We will see each of this in detail. Distributaries. In these distributaries we have two types based on the discharge or based on the volume of water which they can carry and based on the section. You have two types, one is the major distributary, the second one is the minor distributary. The last one is a field channel or water course. Now see, what are canal headworks? Canal headworks are the headworks constructed at the head of the canal, as simple as that. Some mechanism which is constructed at the head of the canal, at the offtake point of the canal, is called a canal headwork. Some structures, some hydraulic structures are constructed at the offtake point of the canal so as to facilitate drawing in of water from the river into the canal. And now what is the aim of constructing a canal headwork? You see, a headwork is constructed for storing water on the upstream side and diverting the same into the canals for irrigation purposes. There are cases where irrigation channels can also be used for navigation purposes. You all know what navigation is? It can be used for transport, for moving just as a road. You use the canal for transportation. That is a navigation canal. Sometimes in big canals, the canals can be used for navigation too. Now here we were speaking about the headworks, canal headworks. It is used for storing water on the upstream side. I was telling you, any canal, it originates from the upstream side of a river. Please make a note of it. It originates on the upstream side of the river. You see here. Therefore, when a structure is constructed like a dam, a barrage or a weir, water level is stepped up on the upstream side. and hence water is stored for some time. These headworks help in storing the water on the upstream side and diverting the same into the canals for irrigation purposes. This is the aim of constructing a canal headworks. Now, what is a regulator? Regulate, to control, is it not? To control, to draw as much of water is required. That is a head regulator, that is the function of a head regulator. The openings with regulating shutters constructed to draw the supplies of water from the reservoir into the canal is called the head regulator. Please note the definition. I repeat, the openings with regulating shutters, the gates can be opened and closed. When you open, the water gets into the canal. The size of the opening also depends upon the amount of lift you give to the gates, also depends upon the amount of water you need. Based on that, you lift the gates or the shutters. And when you lift the shutters, the water is supplied from the main reservoir into the canal, and such a mechanism is called the head regulator. And you see, here is a beautiful picture of a head regulator. You see, the water is all stored here on this side. This entire reach of the river, behind this is the head regulator, is it not? Behind you can see a body of water. That is the upstream side of the river. This entire course, river is originating from somewhere here, it comes along, it is stored, the water is stored here, water level is stepped up here. The entire place is called the upstream side of the reservoir, and here is the head regulator. You can see this is a gate, this is another. When you lift up the gates, water from the river gets into the canal. This is the main canal. Okay, enough. There must be multiple advantages, is it not? For this particular head regulator, there is a wonderful advantage. That is, this will also prevent the entry of silt into the canal. Silt, the fine particles of soil which you see suspended in water. Okay, literally, when you want me to say it in Telugu, neelu buradaga anipistayi. Those particles which the water carry is called silt. Okay, I am not going into the other engineering aspects of silt because these will be covered in the ensuing classes. And now, what is a main canal? A canal which takes supplies directly from the headworks is called the main canal. You have seen the head regulator. Once the gates or the shutters are lifted up, water enters into a particular streamlined canal, and that streamlined canal is called the main canal. Okay, and directly, let me tell you, this main canal does not cater directly to irrigation. This means you can say this takes water to a certain extent, to a certain length, and it feeds the branch canals, that is all. Its main duty is to take water from the river and hand it over to the branch canal, send it to the various branch canals. So, it helps indirectly, it does not help directly for irrigation. That means it does not directly irrigate or it does not water the command area directly. And here is the main canal. We have seen the head regulators, is it not? They are somewhere there behind this here. This part is the head regulator. Water has entered into the main canal, and see how it takes off. See, it is taking a turn because this has to be taken to hundreds of kilometers along the stretch to feed or to cater to irrigation purpose of the entire area. About thousands of acres of land will be can be irrigated, crops can be grown. This is how a main canal moves on. Branch canal. This is a canal taking off from the main canal for covering the entire area to be irrigated. One important thing which we have to note down is a main canal has a bigger section. Obviously, it is handling a large volume of water. So, its section will be more, okay, and relatively the branch canals section will be lesser, because there will be number of branch canals aligned along the path. And now the section of the canal will be less than that of the main canal. This is what I was trying to tell you. And now from the branch canal, the next stage would be the branch canal would take the water, and from there these distributaries would draw the water. Distributaries are canals with much lesser cross section. Okay. A main canal has a bigger section, a branch has a lesser section, and now a distributary has a much lesser section. See, now I was telling you there are two types of distributaries, major distributary and minor distributary. Now let us see what a major distributary is. A major distributary is a canal in which water supplies from the branch canal are received and distributed. Okay. Now the section is smaller than that of the branch canal, simple, a smaller one. This is a smaller one when compared to a branch canal. The discharge is between 1.5 cumex and 5.5 cumex, that means 1.5 cubic meters per second. And next, this is how it looks. See here, this is a beautiful distributary, a live photograph. This particular section, you can see this is also called as a siphon canal because this is a roadway, okay, and the canal is crossing in this direction, in a perpendicular direction. When the high flood level of this canal is more than the road level, what happens? This roadway will be eroded. So what do you have to do? You have to reduce the bed level of the canal at this junction. Just below the road, the bed level is reduced. So water enters here, and it again by siphonic action it comes down. It's something like this. Just watch the cursor. Water enters like this, the bed level is reduced, so water goes down below the bridge, and again it comes up through siphonic action. Okay. This is a wonderful picture where we can also explain the siphonic action of water. Now this is a minor distributary. Minor distributary. See, till this junction the state government will take care of all the supplies. This is the responsibility of this is the distributary. Okay. This particular one, this parallel to the screen, watch the cursor movement. This is a distributary. From here water is drawn by the farmers. Okay. As I have been telling you, the section is much lesser than that of a major distributary. See, this is another one. And now let us see what a minor distributary. You can get some literature here. The purpose is same as that of the major distributary. Discharging capacity is less than 0.7 cubic meters. So obviously here you can see that the section is much lesser than that of a major distributary. Here is another beautiful picture. Okay. This is the distributary from where water is drawn by the farmers. Field channels or water courses. I was telling you, from the distributary water is drawn into the field channels from where the farmers will directly draw the water. Now they are very small. What are field channels? The very small channels constructed and maintained by cultivators in the fields. You see, the maintenance or the construction, the government does not take the responsibility of the field channels. Here this area has to be taken care of by the farmers or cultivators. The supplies from the distributaries are drawn into the fields through the outlets. What is an outlet? You have seen in the previous figure a small sluice, a small pipe through which water is being drawn. That is an outlet. Okay. From that point the cultivators draw the water and they water their fields. This is something like this. And now let us see the cross section of a canal in cutting. Sometimes you may have to dig the area and make a canal there. Sometimes it may be different. So, there are various types of cross sections of canals. The first one is the cross section of a canal in cutting. Cutting means you excavate the area and make a channel. You dig the area. Excavation means digging. Digging the area and making a channel. See, when the full supply level of the canal is below the natural ground level, the section is said to be in full cutting. You see a figure, you see a diagram wherein you will be able to grasp it much faster. See here. Okay. This is the natural ground level. This dotted line is the natural ground level, and this canal is excavated below the ground level. Is it not? This blue line which you can see is the high flood level of the canal. The water level under abnormal conditions also would not be more than the level here, indicated here. So, the entire cross section of the canal is below the ground level. Okay. Such a cross section or such a canal is said to be in cutting. You have made an excavation and here is the canal. The next one is a cross section of a canal in embankment. Embankment means it is raised over the ground level. Raised over the ground level. When the bed level of the canal is above the natural ground level, the section is said to be in full banking. Banking means you are putting in earth there and you are building up a bank, that is called banking. Now, see the figure here. This is the ground level. So, the bund, the berm and the canal, everything is over the ground level. In the earlier slide, I was speaking about the high flood level, is it not? In this particular case, the bed level itself is over the ground level. This is a canal which is laid in embankment, that means over the ground level. The bed level is over the ground level, fine. This is the second case, and in the next one we will see the cross section of a canal in part cutting and part embankment. That means a part of it is over the ground level, a part of it is below the ground level. When the full supply level of the canal is above the natural ground level and the bed level is below the natural ground level, the section is said to be in partial cutting and partial banking. Now, let me explain it to you with the help of a diagram. Here it is. This is the ground level. This is the ground level. See, the high flood level is somewhere here. It is above. The bed level is below the ground level and the high flood level is above the ground level. Such a canal where the HFL is over the ground level and the bed level is below the ground level is called a canal which is aligned or which is made in part cutting and part embankment. Okay. Now, see, let us see what berms are. They are the horizontal portion on the sloping bund. They provide discontinuity in the continuous portion of the slope of the bund. You see, whenever a canal is to be made, we see there are banks on either side. These banks, we cannot give steep slopes to it. They must be as flat as possible. They must be as flat as possible. When it is very steep, they pose certain difficulties. Therefore, to reduce the slope, these berms are provided. See, this is how they look like. Instead of giving a continuous slope, see here, instead of giving a continuous slope like this, here is a discontinuity which is provided here. This horizontal portion all along the embankment is called a berm, okay, on either side. The main purpose is to provide discontinuity along the otherwise continuous slope. Otherwise, the slope would have been continuous, but this berm will give a break in the continuity. Okay, that is a berm. This green portion on either side all along the embankment is called a berm. And now, what is a balanced depth of cutting? Any project has to be financially viable. That means you have to use the resources which are available there. Am I right? So, in the cross section you have seen we have made a canal and you have made banks on either side. So, why not we use the earth which is excavated from the canal to make the banks? Okay. We have to use, or preferably it would be better if the amount of soil which is excavated from the canal be used for the banks on either side. Such a depth is called the balanced depth of cutting. You see, the canal is said to be in balanced depth of cutting when the soil from the canal excavation is equal to that required for the banks of minimum sanctioned freeboard, top width and slopes. Let me explain to you this part of the definition. The banks of minimum sanctioned freeboard. Okay. There is certain tolerance given for the water level, that is called the freeboard. To cater to all this, the banks need to be of certain height. Okay. The banks need to be of certain height to cater to the freeboard, top width and slopes. For all this, to make the banks you need some soil, and that soil which is required to make the banks is equal to that obtained from making the canal. Under such conditions, when both the volumes are equal, volume of soil excavated from the canal and the volume of soil required to make the banks, when both of them are equal, then the cutting, such a cutting is called the balanced depth of cutting. And lining of canals, canal lining. Canal lining is nothing but an impervious layer. What is meant by impervious? There will not be any holes or voids which will allow the percolation or seepage of water through them. Such a layer is called impervious layer. An impervious layer is provided to the bed and sides of the canal in order to control seepage losses. Seepage means flow of water through the sides of the canal. What happens when the seepage is more? Most of the valuable water which is to be intended for irrigation is lost. The purpose of irrigating a much larger area will be lost, and hence we need to minimize the seepage losses. That means percolation or seepage of water through the sides or through the base of the canal. In India, most of the canals are unlined. No lining is given to the sides and bed. Okay. When you improve or when you give a lining to the canal on the sides and base, all these factors, the losses can be taken care of and a much larger area can be irrigated. And now this is a lined canal. You see here, this is the lining, and this is a lined canal too. This is an unlined canal. Please watch this banks here on either side. There is no lining. It is the natural earth. The earth which is dug here is placed on the sides. On the other side too. Fine. This is an unlined canal. By lining, we can discharge more water to the lands. Much of the water, much valuable water can be useful for irrigating a larger area. A larger area can be irrigated. So, are you comfortable with the lined canal and unlined canal? A lined canal is where a lining is given on the sides. We can use different materials. You can use cement mortar, you can use asphalt, you can use bricks, burnt bricks on these sides, and you can use shotcrete. Shotcrete means a slurry of cement mortar is sent under pressure along the lining. By using various materials, you can give lining to the canals. So, the main purpose would be you will be increasing the life of the canal, you will be able to handle more water, and the growth of weeds which you can see on either sides, these will reduce the velocity and therefore it will be a hindrance to us. So, all these can be controlled by lining the canals. So, in this class you have seen what a canal is, main canal is, the network of canals, the branch canal, the major distributary, minor distributary, field channels. You have seen the cross section of a canal in cutting, embankment and partial cutting, and you have seen a lined canal and an unlined canal. You will learn more in the next session.